Today, we are going to find out which type of fluid flow has the greatest amount of heat transfer, laminar, turbulent, or no flow. But first, let's understand what heat transfer is and how we can measure it.
What is heat transfer? Heat flows from areas of hot to cold by convection in liquids and gases. The cold object absorbs the energy from the hot object, and both equilibrate until they're at the same temperature. This is what happens when you forget about your hot coffee until it becomes room temperature. This movement of heat from hot to cold over an area is defined as heat flux. Sir Isaac Newton discovered a formula relating the heat flux to the change in temperature, Newton's law of cooling. To do so, he defined a coefficient H, the convective heat transfer coefficient. H changes depending on the fluid's properties, the system's geometry, and the type of fluid flow. Because every H depends on so many different factors, scientists scrambled for a way to calculate it easily. Today, we'll be using these formulas they created, and with that H, we will find out how much heat is transferred through different types of flow.
The heat transfer coefficient is a value that represents the efficiency of a fluid to transfer heat away from or to a surface via convection. Rearranging the equation for the Nusselt number gives that H is equal to the Nusselt number times the thermal conductivity of a fluid over the characteristic length of the surface. This value is equal to the constant 0.678 times the square root of the Reynolds number divided by the characteristic length.
The Nusselt number is defined as the convective heat transfer coefficient times the characteristic length over the thermal conductivity of the fluid. It is a ratio that tells us whether convection or conduction dominates the heat transfer.
What are the different flow regimes? Laminar flow looks like this. It's smooth and orderly. Turbulent flow, on the other hand, looks like this, chaotic and random. No flow is, well, no flow. We can tell which type of flow it is by finding the Reynolds number.
The Reynolds number is the ratio relating the momentum of the fluid to its viscosity. The Reynolds number is found by multiplying the density of the fluid, ρ, by the length of the plate, L, and the velocity, v, while dividing by the viscosity of the fluid, mu. The Reynolds number defines the two types of flow, turbulent, which has a Reynolds number greater than 300,000, and laminar, which has a Reynolds number less than 300,000.
In this experiment, you will need a metal plate, we use stainless steel, 2 thermometers, the top of a liter bottle with a small hole in the cap, a measuring cup, some strong tape, a shower, and a bowl to catch the water. First, tape the end of the bottle to the shower head. Adjust the shower flow until it looks laminar. Let the water flow over the vertical plate, catching it in the bowl at the bottom. Make sure to measure the temperature at the top and bottom of the plate and the time over which the water is caught. For each run, measure how much water is collected in the bowl over the timed period. We will use this volume over time to find the velocity of the water. Also, measure the area over which the water was flowing on the plate. This is the width, and the height of the water is the height. Repeat this procedure with the shower producing turbulent flow. Now that we have collected initial and final temperatures, time, volume, and area, we can find the velocity of the flow. With this velocity, we can find Reynolds number, which tells us if the flow is laminar or turbulent. With Reynolds number, we can find the heat transfer coefficient, H. Finally, we can use H to calculate the heat transfer over the plate. Repeat these calculations for each laminar and turbulent run.
These are our final calculations for each type of flow. No flow was calculated with Fourier's law. These values are negative because heat left the fluid to the plate. We can see that turbulent had the greatest amount of heat transfer as expected due to its more chaotic flow and higher velocity.
Turbulent flow is more efficient at transmitting heat than laminar because the chaotic flow directly moves the hot molecules to all parts of the fluid, whereas laminar flow requires the heat to pass through every single molecule on its way to the far end of the fluid.